Hello again. So today we're going to continue off with talking about the star life cycle, and something that I didn't really mention in the last video was what is also being created when that nebula condenses into a main sequence star. So in one of the videos you actually see it happening, and it says that sometimes planets can be formed as well. Well, today that's what we're going to talk about. It's the formation of our solar system. So once again, there is a set of notes that accompanies this, so you can go ahead and grab that if you're finding that useful. Again, if you're not using it, that's totally fine. So this is going to start with that same nebula that our star cycle started with. Remember, a nebula is that collection of debris. So it's a collection of dust and gases from the explosion of a massive star. So it starts at a nebula, which is a collection of dust and gas. All right, and so it's going to start condensing more and more and more. All right. And that's because of the dust, debris, and the gas all being attracted to one another due to gravity, and also because of the pressure of the space around it, right? So as it begins to condense and condense and condense, it starts to actually rotate. Because the pressure is uneven, it starts to rotate. If anyone watches rugby and you watch a scrum and they hit each other and then someone starts to move on the side and exert a little bit of uneven pressure, what happens to that scrum? It starts to rotate. And the same idea happens here with the nebula. So you have everything pushing in together, but the pressure isn't quite even, and so it starts to spin, it starts to turn. Okay, so that's what this is showing. It's showing that it's just starting to rotate around. As the nebula begins to collapse under the force of gravity, the speed of rotation is going to increase. So as it's no longer a ball, as it's starting to spin, it's going to start to collapse, kind of like a flat pancake. And as it does that, because of, again, all this pressure, the spin is going to get faster and faster. Okay, so it begins to rotate as nebula collapses under the force of gravity. The rotation increases its speed. Okay, so as it starts to speed up and speed up and speed up, what happens is this kind of like squash pancake starts to spread out. So it starts as a ball, starts to spin, and as it spins, everything gets spread out more and more and more. And you kind of think about those pizza dough, those pizza restaurants where you have the master chef throwing the dough up in the air, and it starts as a little ball of dough, and he's spinning it and spin it in his hands, and the dough gets spread out more and more and more and more until it's this big massive pancake. That's what's happening here. So the speed of rotation increases, and it causes the matter to spread out. All right, at the center of this pancake, though, you'll notice that there's kind of this circular thing, this bulge in the middle, and that's eventually going to be that main sequence star we talked about in the last video that has its own life cycle. That's where our star is, it's our sun. So at the middle, that is the middle of the dough isn't rotating as much as everything on the outside is. So this inside stuff is really starting to condense and form that main sequence star. And since we're talking about our solar system, eventually forms the sun, because our star gets a special name. All right. So as this is happening, things are also starting to cool down. So it was a really hot explosion. All this debris was there. There's all these gases. They're super warm, super hot. And then everything starts to cool down. As things start to cool down, the smaller clumps of cooler matter that are closer to the center start to form what we call protoplanets. So the smaller clumps of cooler matter begin to appear. And that's what you can kind of see happening here, here, and here. They're just showing that these clumps are starting to kind of condense. And they're starting to, not only are they still attracted to the center of the solar system, but they're also, these little clumps are starting to kind of be attracted to one another as well. So smaller clumps of cooler matter begin to appear. We call those, that's supposed to be an arrow. Wow. These are protoplanets. Didn't think it was possible to have worse writing than my whiteboard writing, but I've been proven wrong on that. All right. So forced together by gravity, these protoplanets are also attracted to one another. They eventually condense in on themselves and form planets. And that mysterious force that's making them do all this is, again, gravity. Going to form planets. Okay. Once the protoplanets are formed into defined orbital paths around the sun, they became our planets that we see today. One of the reasons that Pluto is considered a dwarf planet and why there's all this contention about Pluto, it doesn't have its orbital path intersects another orbital path, and it's not quite as set as other orbital paths. But these outer planets, so if you notice when we're talking about the inner planets like Mars and Venus and Earth, there are these smaller, harder planets that have a surface, but all the outer stuff was kind of just all this extra debris and gas that got swept up into these large gas giants. And that's why the large gas giants are on the outside. They have less dense material, so they got spread out further, and it's all the extra debris that just kind of got swept up and accumulated into these gas giants. Okay, so planets formed, defined orbital paths, and outer planets, and the outer planets okay, just 1 second, sweetheart. Swept. Just watch. Remaining debris and became larger. Larger.
I did it too.
All right, so that is how our formation of planets occurred. So hopefully after you've watched the intro videos, you've gone through this video with me, and you watched some of the other videos that we provided, you'll be able to answer these 3 questions. The formation of planets occurs during what other process? So what did we already talk about forming that I didn't mention the planets for? So what else did this our planets were formed? What was formed in the center of it, basically? What do some stars have? Why do some stars have planets orbiting them and others do not? And how does the formation of our solar system provide evidence for the concept that the universe is changing over time? Thank you very much for joining me again. I hope that helped. If you have any questions, please let us know, and we will see you soon.